Hello, so my name is Michael, and I wanted to take some time to explain how, based on my experience, what's the best way to screen developers, software engineers. And for those who may not know, I founded a coding school, one of the oldest coding school in the world, called Coding Dojo, where in the last 10 years, I trained over 10,000 students who now work over um, lots of different companies, including almost every single Fortune 500 company have hired one of my students. Before founding a coding school, Coding Dojo, I also led software teams and I also coded myself. I've been coding for the last 30 plus years. So I have quite a bit of experience programming, leading teams, as well as training people and helping them find jobs across various software sectors. So based on my experience, I wanted to share with you, if I was to go back in time, and interview software engineers or screen developers, what I would do now compared to what I have done previously. So hopefully these stories and experiences will help you gain perspectives on what to do and sometimes more importantly, what not to do when screening developers. Okay, so when I say developers, I'm going to mean software engineers, not those who build houses. We're going to be talking about those who develop softwares, okay? And I'm going to call them developers, just to make it easier because it's easier to say developers than software engineers. And I'm going to have my iPad here where if I need it, I can explain some things through drawing. I find that based on my experience as teachers, there's nothing better than a whiteboard to explain things, although we could add fancy animations and other things. There's something powerful with the whiteboard. So I'm gonna use that. Although I have one on the back, if I write something on the back, it's not gonna be as visible as me pulling something on the iPad and drawing something here with you. But the way that I want to explain this is not going to be just telling you what the final answers would be. I want to explain my thought process and I want to kind of have you gain perspectives on how this industry works and um, why doing some of the things I'm talking about will be effective. How sometimes is not as important as why. So I'll go into some of the why. So imagine first that you're either a new hiring manager or you're working in the HR and you've been asked to help the company find software engineers or developers. What do you do? Well, oftentimes what happens is the hiring manager, the manager of the developer that the team is looking for, fills out what's called the job requirement or job description. And often the job description goes something like this. It says, I'm looking for certain engineer, and this could be Java, this could be PHP, this could be Python, this could be JavaScript, this could be C Sharp, Objective C, Perl, Fortran, the list can just kind of go on and on. And it usually says, we're looking for someone with X years of experience who knows A, B, C, D, E, F, G, and the list just kind of goes on and on and on. And this is very common, that for a job description, it lists a bunch of technologies and keywords, many of which you may not be familiar with. And you're asked to find developers who meet these criteria. And when this happens, this can be quite overwhelming, especially because one, you may not be a developer yourself, and you may not know what these technologies mean. And that can be overwhelming. So you may just go and put out this job description, get a bunch of people to apply, and you may be surprised that not a lot of the developers who submit their resume actually know some of the keywords that are in the job description. And when you do that, do you throw those resumes away if they don't list all the technologies that your job is requiring? Or do you not look at that and just find developers who meet some of the requirements? Well, to give you a clear answer, um, it, I think I must first kind of explain at a high level how some of these technologies and keyword comes into play. And of course, the company culture is also important as well as the hiring managers. It depends. Some hiring managers may really need someone who knows all of these. Some companies may be more open or whatnot. But first, before we go on, let me first kind of give you a big overview of this industry, which took me a long time for me to learn because most developers like me usually spend 5 to 10 years really mastering one programming language and tools that surround that one programming language. And usually that's the area they stay within that one language. For me, it took me a long time to master several programming languages. So now I know how to do desktop development, mobile development, web application development. I know over a dozen plus programming languages, but it took me a long time. And when I only knew one programming language, I wasn't sure if what worked for one language was applicable across multiple different languages. But now that I have about 30 years of experience in the software field, I have a bigger perspective on how this industry works. So let me turn my iPad back on and let's explain how this industry works. And I did create another video explaining how a web application works, and I used an analogy, but I'm going to give you a high overview because I feel that as a hiring manager or as a recruiter, knowing a high level how things work will really help you identify what technologies are important, what technologies may not be as important, and so forth. Okay, so the analogy that I'd like to use to explain how all of this works, especially when it comes to web application, is an analogy called Ikea store analogy. So I'm going to use that just now. Just bear with me and this will make sense. So, okay, the Ikea store analogy goes like this. Imagine that there is an Ikea store and you got lines of people waiting to enter the store. So the 3 arrows here mean bunch of customers who are waiting in line to enter the store. And the way that this store works is they got, let's say, just to make this example simple, we'll say they got 3 receptionists within the store who talk to these customers, and the customers walk in with an order form. And that says, I want 3 IKEA chairs, 5 of these, 7 of these, and so forth. So they come, they line up, and once the receptionist takes the order form, the order forms are given to the workers. And imagine the workers speak a language within themselves to communicate and to process the order. So in this example, we'll just say they're speaking English as their main language to communicate with each other. There's also, let's say, a warehouse where all the different parts of the IKEA store are stored. Legs, tabletops, different chair components, and so forth. So the receptionist, once they take the order, gives the order form to the workers who goes to the warehouse to retrieve different, they go to the warehouse. There's a guy here, a warehouse manager, who works with the worker to pull different parts of inventories in the warehouse. The worker goes and assembles and put together those different pieces, hands it back to the receptionist, and the receptionist hands off the finished furniture back to the customer. Okay? All right. So that's simply, let's say, how this specific store works. Very simple. The customer comes in, hands off the order to the receptionist. Receptionist sends the order to the workers, who then goes to the warehouse where there's a guy who manages the operation within the warehouse, and they pull together different components, and the workers assemble it together using the language, in this case English, and then they give off the final product to the receptionist. So let's talk about web applications here first. So in the web application, the store analogy applies. How does it apply? when you open a browser and when you type in, let's say, datacompass.com or any website for that matter, it goes to, there's a little bit more complex process called a DNS server, but let's just skip that. Somehow, by typing that domain name, datacompass.com or whatever, the internet knows which specific computer it needs to talk to. So it's routed. So it finds that computer, which is represented, the store itself, the Ikea store represents the server, the physical server. And within that server, there is a web receptionist who receives that request. And this request on the web is called HTTP request. So HTTP request hits the server. There is receptionist here, which is often called the servers. It may be a little bit confusing because the server represents the whole store, but also the web server is representing a small part within that server, the receptionist. The web server basically takes that request and gives it to the workers. And the workers may be speaking in different programming languages, and this is where the backend comes in. Anything that happens within the server is called the backend. So the workers, you can have people speak PHP, Python, Java, C#. What are some other languages? JavaScript, Node. We'll put Node because Node is more for the backend. And you can use, there are many other languages you can do. You can do it using Go, and Ruby is one of the other languages you can use. So there are many different languages that these workers can use to work together and put together that furniture, right? There can be a warehouse, but this is usually called a database, where the database has a lot of information stored. There are different types of database over here. I'll put that in green. There is a SQL. There is also a NoSQL. Okay, within SQL, this can go into, for example, MySQL, Postgres, Oracle, okay, Hadoop, Cassandra. Some examples of NoSQL could be MongoDB, Redis, memory-based database. So just as you can imagine, if you built an Ikea store and you were to organize all the different inventories, and imagine I had 10 people and said, 10 of you organize all the different parts within the Ikea store, however you think is best, not all 10 of them would store all the parts exactly the same way. Right? You can imagine one would say, okay, I'm going to organize my shelves this way. Another may say, I don't agree. I'm going to organize it this way, and so forth. It's exactly the same. For a web application, there are so many different ways that you can organize the database. One optimized for certain tasks, one optimized for another task, and therefore there are just a lot of different databases. But if you're screening for developers, you don't necessarily need to know all the complexities within each of the database. The good news is if you know one, learning another can be very, very easy. So it's not such a big deal. Except if you haven't done anything with a NoSQL or non-relational database, switching may be a little bit hard, but we're talking about maybe a few days of adjustment, not years of adjustments and learning curve. Okay? All right, so that's the database. The backend workers, again, just as they could speak different languages to assemble IKEA furniture stores, you can imagine they could be speaking Chinese, English, Korean, whatever, to assemble the furnitures. Same thing on the backend, to deliver the response, HTTP response that the customer is looking for, the workers can put that together using PHP, Python, Java, C#, JavaScript, Node, Go, Ruby, or some other languages to put the pieces together. The pieces that are put together, the HTTP response that it sends back to your computer to be rendered on the browser, is always in the form of HTML, CSS, or JavaScript. Okay, HTML contains information. CSS basically dictates how that information should look or should be styled. JavaScript has instructions for your browser to handle interaction. So what happens when you click on something, when you hover over something. So these events that happen within your browser and what to do, those instructions are carried in JavaScript. So at the end, regardless of whether you're looking for PHP developer, Python developer, Java, C#, Ruby, Go, Node.js, or whatever, you're just putting together HTML, CSS, and JavaScript together based on what the customers are looking for, what pages your customer is looking for. Okay, so this is kind of how it works. Now, I need to explain a little bit more because this explains maybe about 50 to 70 keywords that you see. Okay, but there is more to it. You can imagine when the operation gets really complex, how you put together information could also become very complex. So the way that you organize these workers to put together HTML and CSS and JavaScript, especially as the application gets more complex, there are usually frameworks to help organize these code. So yeah, so let's pick, for example, Python as an example. So yes, these workers are putting together the HTML, CSS, and JavaScript in Python, but Python codes could become really, really long. And if the codes are really long, when you have 20 developers working on the code, it could be very confusing among the 20 developers how to organize the code, because you don't want them to replace or erase what someone else wrote and write their code and causing bugs. So the way that these instructions for the workers are organized are usually done using frameworks. So I'll put that on. Frameworks. Okay, frameworks are basically just a way to organize your code to make it easier for someone else to understand. And there are, again, just like there are many ways to organize database, and that's why there are so many different databases, there are so many ways that you can organize your code in Python or PHP or Java. But at a high level is most of the web applications are using what's called an Nvc framework, which is very simple. That means any code that has to do with a database, we'll put that in a folder called models. Any code that has to do with the HTTP response or what the user views will go into the views folder. Any code that exchanges that deals with information between the model and the view, we're going to put that in the controllers folder. Okay, so this is kind of the common way, although some of the frameworks have a different opinion. Python, for example, one of their most popular framework, Django, uses a slightly different name for it. Okay, but this is why this is interesting. Although the backend language may have been done using just simply Java, there can be multiple frameworks to organize the code. Now, these frameworks, some have been around for years, some are quite new. But the tricky thing is these frameworks are built by other developers, and it embodies their philosophies. And again, one developer may have a different philosophies about how the code should be organized than another. So usually within a language, there are various frameworks, and an experienced developer can create their own new framework, usually by spending a few days to maybe even a week. You can create a very light framework from scratch, and you can give it its own new name. Okay, so it's interesting. Although most of the web applications are built using one language, one of the things that I listed, and there are some others, there are multiple frameworks because again, there are many different ways that you can organize your code. Okay, all right. Same thing with the HTML and CSS and JavaScript. As the web applications become a lot more complex, you can imagine the JavaScript instructions become really complex too, because now the browser is asked to handle a lot more response than before, a lot more interactions. So within JavaScript, there are a lot of frameworks to organize the JavaScript code. And this is where, for example, React, Angular comes in. There are other ways where you can type a little bit less to render HTML and CSS, and that's where things such as Haml, Sass, Less, TypeScript kind of comes in. Those are just to write HTML, CSS, and JavaScript more concisely. So there are tools around that. There are a bunch of frameworks around JavaScript that help browsers render, and for developers to look at it and for the codes to be more organized, especially when the JavaScript gets really, really big. So a lot of single-page applications like Google Doc, Google Slide, those things has a lot of interaction. So if you can imagine, if 20 developers are working on it, they really want that code to be organized, which is why they use a framework such as React and Angular. But again, frameworks can be created by an experienced developer very quickly, the light framework at the very least. For example, as one of the homework assignment, I would actually have someone create a framework such as Angular or React or Django within a week. And many of them are able to do it within a week. Some are able to do it just within a few days. It's not that hard to create a framework. Okay, so with that said, let's go back to that scenario that we started with. So that was kind of a long way to explain this, but this will make sense. So again, you're a hiring manager or you're working in the HR, you put out a job ad, the one that your supervisor told you to put, and you get lots of people applying, okay? If you were looking at the job description, okay, so let's say you were looking for a Python developer with X years of experience, who's familiar with, so I'll be a little bit more detailed, with MySQL, Redis, HTML, who knows Haml, CSS, who knows responsive web design, who have used, for example, Bootstrap, Foundation, someone who knows Python, Django, and someone who also understands ORM, and someone who has done with Amazon Cloud, ECS, EC, blah, 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 blah. Okay, and the list can go on and on. Now, with some of the explanations that I've done in the past, hopefully this will kind of be like, oh, okay, I have a little bit more sense on what this is about. This is the database component. This is HTML component. Haml is just another way of writing HTML that's more concise. CSS, that's how informations are displayed on the web browser. Responsive web, this is basically how to style your website so that it looks fine on your mobile and it responds. The screen responds based on the width of the browser. Bootstrap foundations are just some of the libraries and frameworks that deal with CSS. Python is the backend programming language, and Django is a framework. ORM is just one of the concepts on how the models, how the database layers work. I won't really explain much. Amazon, ECS, and these are just another way of deploying your web application. So all of the web applications jobs basically fit into these categories. Okay, most of the there are lots of frameworks, as we talked about. Within each framework, there are a lot of tools. Again, if I told you that a framework can be created by an experienced developer within a few days to a week, right? At least the initial version, tools or libraries within that framework are even easier to create, or in Ruby, that's called gems. So someone experienced can create these frameworks really quickly. They can even faster create these tools and libraries. So let's just do a high level. Okay, so for any programming language, so let's just list some, right? C#, Java, Python, Ruby, PHP, Node.js, Objective-C, or let's also put Swift. This is Swift, for creating that. There's also JavaScript, because now JavaScript can be used not only in the backend for Node.js, but also it can be used using tools such as React Native to create mobile applications. So we'll put that on. Okay, so within each of the language, you can imagine they have lots of different frameworks. And again, frameworks can be created pretty easily. And again, frameworks are just codes that other people wrote, that other people can leverage. And so you can imagine within each of the framework, there are tons of tools. So there can be dozen to a few hundred tools within each of the framework. So if you were to do, let's just do a very quick math. Let's say here I listed about 8. So let's just say there are 10 different programming languages out there that are most commonly used, which is probably a safe assumption. 10 most popular. And then within each of the frameworks, just imagine each of the language, there are 10 frameworks, popular ones, again, because I can ask one of my students or myself to go and create a new framework from scratch within a week. But let's just say there are 10 that are most commonly used in the industry for each of the programming language. And within that framework itself, there are tools or libraries, let's say 100 of them within each of the framework. How many keywords would be common or would be what people are looking for? Well, according to this math, just doing a very quick analysis, rough, that means there are about 10,000 keywords, probably, right? Now, some are for web, some are for desktop. You can use, for example, Objective-C, Swift to create iOS desktop application as well as mobile. You can use, for example, C# to create desktop application. You can also use Java not only to create web applications, but also desktop as well as mobile applications. And if you're creating desktop applications, sometimes you use a different framework built for that. But anyway, with this, the high level is there are 10,000 plus keywords that will be out there. And with new one being created probably daily. Because again, these frameworks and these libraries are not hard to create. Okay? All right, so that makes recruiting really hard. So your new recruiter, with the job description, it has 25 keywords. Now, we've just done this calculation. There are easily 10,000 keywords that are out there. How many developers would actually know these exact 25 keywords that are listed in this job description? Very rare. Unless you're looking for very, very common keywords. It's hard to find these because it takes usually years for a developer to get exposed to one programming language, one set of framework, one set of tools, and they usually spend 5 to 10 years really mastering that before they look elsewhere. So that poses a big problem, doesn't it? As a recruiter, when you're looking for developers, if you're looking for someone with specific keywords, which is often the case, you may not be able to find that person very easily. So what do? Do you just cast a wider net? Do you then start accepting people who don't know those tools? Well, I've struggled with that question for years. And this is my point of view now. My point of view is this. But before I explain this, let me introduce another concept, and I will tie this in. Based on my experience, I categorize programming knowledge into 2 buckets. And what are the 2 buckets? Bucket 1 is what I call permanent knowledge. There are things with programming that when you do it, and just like knowing how to ride a bike, once you got it, it may have been 10 years ago or 20 years ago that you used it, but you still have it, and you can hop on and it's still with you. That's what I call a permanent knowledge. Just like knowing how to ride a bike. If you knew how to ride a bike 10 years ago, you still do now. Okay? Another one is what I call the transient knowledge. Transient knowledge, unlike permanent knowledge, comes and goes. And usually when it comes to programming, if you haven't done something in the last week or so, there are often things that you just forget. For example, let's say I've been programming in Python for the last week every day. Although I may know 10 different programming languages and I may be very good, because I've been using Python for the last 7 days all in a row, my mind might be stuck in the Python mode. And if you ask me a trick question on C# or Java or JavaScript, and I may have done it a year ago, man, there are so many things that happened in between that period that unless I've done that recently, I'm not going to be able to remember. And those, I'm going to put that into what I call a transient knowledge. Knowledge that you may have before, it may come back to you, but again, it's something that you easily lose if you haven't been doing it every day for the last week or so, or maybe even the last few weeks, or even the last few months, okay? So it's important to realize this. So when interviewing or when screening developers, my philosophy is this, that when you have a job ad, it doesn't matter what the job ad is. When you're looking for developers, it's not whether they are a good fit or bad fit, or good developer or bad developer. No, it's not so simple. You got to look at two things, okay? You got to look, how good is their programming IQ? Programming IQ is a term that I come up with, okay? How good are they as a developer? And this is what I would consider a permanent knowledge, as the name signifies. And this is a term that we came up with to explain. But programming IQ for a developer, and the name I think does a pretty good job, but I need to explain this a little bit more. Regardless of what programming language the developer may have been used to, some developers are just really good at solving things using the fundamental building blocks of programming. And again, when it comes to programming, in my opinion, there are really only 5 building blocks that you're asked to use to create anything. And every single programming language really has these 5 building blocks. Variables, understanding variables, if and else statements, loops, including for loop, knowing how to use functions, and then the advanced how to use object-oriented programming. Now, there are some exceptions, functional programming and others, but really all programming are really built around those 5 building blocks, okay? And the first 4 are really used across everything, right? Because OOP is a concept that's used in some programming languages, but most programming languages have object-oriented programming. Okay, so regardless of the programming language that one may have been exposed to, if they got really used to solving anything using those building blocks, they have a high programming IQ. Some developers don't have a high programming IQ. And they may know a lot of keywords. They may seem like they know a lot, but if you ask them to actually write a code and do something, they really, really struggle. And those are developers who may have a lot of transient knowledge, or who may know a lot of the tools that you're looking for, but they lack the programming IQ. Okay? So this is where it becomes really important. You want to find someone with high programming IQ. Once this is done, then you need to find someone who's familiar with the tools that you're looking for. Okay, now remember this. Frameworks are probably more important than just knowing some of the tools and libraries within that framework. So in the previous example, for example, it's more important for someone to know Django as a framework than someone who understands some of the libraries that are often used in Django. Okay? But even then, Django can be learned by an experienced developer within a few days, especially if they have already been exposed to Nvc Framework. Okay, so with that said, a common mistake done by hiring manager is they have all these people apply for a job. I'm just going to draw some people, stick figure. So they all apply for a job, and the screener basically says, oh, this job description has 25 keywords. Let me see how good they are. Oh, 80% match on the keywords, 90% match on the keyword, 60% match on the keyword, 20%, 15%. So doing this keyword search and eliminating candidates is really stupid. It's not effective. Because what if this person who was really, really good, imagine they actually created the language Python, but they didn't have time to learn about all the different frameworks that other developers created around the language that he created. That person's probably going to get eliminated. Oftentimes, the applicant tracking system does the filtering automatically as if, hey, look, I've already pre-screened candidates and here are the list of people you should interview, 95% match, 25% match. I don't care if you use data science and machine learning to better filter candidates this way. It's wrong. It's not effective. And you're going to be screening out a lot of people with high programming IQ, those who could actually have created a lot of the frameworks and libraries that are being used by these companies. You might eliminate them. Here's another thing too. You might, you unintentionally get a lot of developers who are a good match. They know all these buzzwords, right? They know all the keywords that your job is looking for because those are the very popular frameworks that were introduced in the last few years. Most developers just never had the time to learn it because they were busy in their job. But these guys just were not busy because they were out of work. So they spent all this time learning all these different keywords, and now they get presented. You know what frustrates hiring managers most, more than anything, is to get these screeners, to get these candidates who seem to be well qualified, and then they take their busy schedule and they interview these people and find out that they actually don't even know how to program really that well. They just have a resume with full of these keywords. It frustrates developers and hiring managers because it's a waste of time. They don't have high programming IQ and they're just not a good match. Now, this may seem very obvious that when you're screening for developers, look for someone with high programming IQ. Then look for someone who's a good fit on the keywords and languages. But this is what I would do. And in the past, I made this mistake, so I'm guilty of this. In the past, I was looking for people with certain skill sets who knew these keywords and specific database I was looking at, different database technologies that I was using, and I was trying to find the right match. And a lot of the people, it was hard to find people who met that match. But then once I gave them a coding question to see if they would actually build something that I would expect someone to do in 20 minutes, they can't even do it in 2 days. So it would frustrate me, and I felt like I was just wasting a lot of my time. Later, I learned, okay, I need to separate this. I need to find someone with high programming IQ first, regardless of what programming language. So I may be looking for, let's say, Python developer. They don't have any experience in Python. Maybe that's okay. If they have a lot of experience, 5 years, 10 years of experience with another language, then that's okay. And if they have done things with another framework, maybe that's okay. So now what I do is I first look for someone with high programming IQ, and then yes, depending on the role. If I have time to train them, then that's a different story. But if I don't have the time, I can say, hey, I would like to interview you. I know that you have a very high programming IQ based on the previous assessment, but I am looking for someone who's familiar or somewhat familiar with Django or this particular tools and libraries. I know you don't have experience specifically around that, but would you be interested in taking a look into these tools that my company is using today? And maybe after a week or two, after you have some time to digest, would you be open for doing an interview with me? That's one approach you can take. Another approach you can take is just to focus more on principles and not ask them specific framework question, specific tool question, but understand how they think, how they organize their code. Because again, the mistake that you don't want to make is to filter out people with high programming IQ who could have not only used the frameworks your company is looking for, but who could have easily created these frameworks themselves from scratch. Okay? So at this point, another mistake that a lot of companies make is in the beginning, they ask so many questions related to tools and frameworks which I would put into a transient knowledge category, and they weed out all these people that could be a good fit. So you don't want to do that, right? You don't want to, because honestly, even if I have done Django for many years, if I haven't done Django the last 2 weeks, because I was so focused on another framework, and you ask me a question related to a specific version of Django, I may not be able to answer that. Not just because my mode is somewhere else. And maybe that was something I did 2 weeks ago, or 6 months ago, or 9 months ago. I'm not going to be able to remember. So any of those trick questions that deal with specific language or framework or tools should be avoided. But what happens if you're a hiring manager and you're asked to interview someone? I would say by default, a lot of the questions, of course, center around the specific tools and programming language one uses. Again, that can be very costly because you can be pushing away a lot of developers who might be a good candidate. And this is why a lot of forward-looking companies are now focusing less on transient knowledge, what I call transient knowledge, frameworks, tools, and they put more focus on the fundamentals. And I believe that is the right way to go. And of course, once they get the job, then hopefully they will go and learn these different tools and frameworks. But again, focusing first on the programming IQ is really, really, really important. Okay? Okay, so I want to talk about another point. So let's say you do ask questions to find out their programming IQ. What type of questions should you ask? Now, a lot of hiring managers ask trick questions, or they ask questions that are specific to one language. And I find that those are usually not good. Even data structure questions, I don't find they're that good to find the programming IQ, because let's talk about data structures. These are, for example, questions related to singly linked lists, doubly linked lists, hash table, recursions, different ways of searching through the database, trees, graphs, tries. There are a lot of different data structures that can be used and that are taught often in computer science. And oftentimes people ask those data structure questions to see if someone's a good programmer. I find that those aren't that good because, again, let's ask ourselves. Those questions that are often very much asked during interviews, data structure questions, right? Hash table, binary search tree. If someone hasn't done it in the last 12 months, do you think they will know how to do all of those? And if you ask any developer that, I would say 95% plus will say, if I haven't done that, if I haven't reviewed those concepts in the last 6 months or 12 months, I wouldn't be able to answer them as well as if I studied it and reviewed it in the last few days. Okay, I would even venture to say 99% of developers would agree. It's sad that often these questions are asked during interview because I don't think that's very effective, but that is done in the industry. So again, with the mindset of permanent knowledge versus transient knowledge, then you ask yourself, okay, so those things that were often taught in computer science, is that permanent knowledge or transient knowledge? Hash table. If you haven't done a hash table for a while, if you haven't done a recursion or used recursion as specific type of data structure to find something, would you be able to do it as quickly as when you were studying it for the last few days? The answer is no, right? Often these questions make the interviewer feel good, right? Because, oh yeah, like, you know, now I'm able to filter people who weren't able to answer these questions. It makes me feel smart. But hey, look, it's not really a permanent knowledge. If you ask any developer, when was the last time you used a hash table or a binary search tree? Most developers would really think hard because it may have been years where they may never actually use those data structures. And you may be asking, if those data structures aren't really used during the real work, why is it asked anyway? I think it's one of the bad habits in the industry. But also back years ago, it was more important than it is now. Now, a lot of things are done at a high level. For example, we don't go and create a new database from scratch anymore, unless you're working for MySQL, Postgres, Hadoop, or whatever, right? But most companies are using technologies that other people have built. So if you aren't creating a new programming language, you're not creating a new database, you're not creating a new service layer from scratch using a low-level programming language, these data structure becomes something that you don't really deal with. For example, in my professional life as a developer, once I've used recursion to solve something, because most of the time I just avoid using recursion at all costs. Data structures, most of the time I have to study and teach it to help my students get jobs. Not that I've ever used any of it in my work. Some concept of object-oriented programming and how to organize data, that's valuable, but not these exact data structure. So if someone was to ask me data structure question versus one of my students who studied data structure every day for the last 6 weeks, my students would do 10 times better than me because I just don't use data structure that much at work. And it's been well, not only it's been years, but it's just not used that much at work. So again, data structures would go more into, in my mind, what's called a transient knowledge, and that's why I wouldn't include them in finding the programming IQ. Now at Data Compass, I built a programming IQ assessment that you're welcome to use for free, and you can find candidates' programming IQ usually within about half an hour. And just like the name implies, once a candidate gets a programming IQ test, as long as they've been working in this industry for a few years, most likely their programming IQ is not going to improve dramatically over the years. It's probably going to stay pretty stagnant unless the developer really tried to focus back on the fundamentals and build that programming IQ. Again, most developers with years of experience, you kind of reach that IQ. And you can find someone who's really good, someone who's not so good. Okay? And this can be done using simple, basic to intermediate algorithm questions. Things that are used almost all the time to build any software component. You're using if and else statements, you're using functions, you're using loops, functions, variables, including arrays, and you're using simple building blocks to solve something. Those are the questions that I would include in the programming IQ questions. Now, one more thing. So once you ask these questions, how do you know if someone did really well? Well, I want us to go a little bit deep into this. How is it that when you ask someone experienced to interview someone, after 20 minutes, 30 minutes, how is it that the interviewer knows how good the interviewee is? And if you think about it, is it a gut feeling? Is it an intuition? It's not. It's based on data. But what data are we exactly talking about? And it's an interesting question. Imagine that you are interviewing someone. Let's say a mathematical question. And you're looking for a mathematician. So you ask a math question, and you want to see how good this candidate is on math. Okay? So you come up with a question, blah, blah, blah. So let's say you come up with a question, and you think really hard on what this question is, and you feel good about this question. And you ask this question to one person. And then I ask you, how good was that person? What would you say? Would you say, well, I think that person's really good or bad? You might have some idea, but if this was your first time asking that question to that candidate, you actually really don't know, right? If that person is good or bad or really bad. But if you interviewed someone else and asked that exact same question, ask another one, and imagine you ask about 10 to 15 more people. By the time that you're interviewing a 16th person or 20th person, and then if I came to you and said, hey, how good was that person? You would be able to come back with the data and say, Michael, I think that person, based on my data, based on my experience, that person is, I would say, in the top 5% or top 10%. Oh, they're in the bottom 20%. Don't even bother. Isn't that interesting? Okay, let's break that down a little bit more because there's something really fundamental and so simple and intuitive, but yet we often don't realize what's happening during the interview. Okay? Now, imagine going back to that question, right? Let's say, that math question that you asked, maybe let's just say had 3 different answers, A, B, C. Because, sometimes there is more than one answer. Not only is important on how fast someone is solving it, right? Because speed often tells how good they are, right? If you're able to solve that in 1 minute versus 10 minutes, you would say the person who solved it in 1 minute is better than someone who solved it in 10 minutes. But there's another factor. Speed is not the only factor if you think about it. Sometimes accuracy also plays a big role. Maybe they were only able to find 2 answers, but there were 3 answers to it. And they weren't looking at the third perspective, right? Coding is really solving for all different edge cases. Solving it when, for example, the number that you get is negative. What if it was, instead of a decimal that you were looking, it actually passed an array back to you? Okay, what if it actually passed a function instead of a variable? Things like that. So these often assumptions that we have to validate. If a developer doesn't ask those validation questions or doesn't think about these edge cases, that's what often leads to bugs, right? So for a good developer, they need to think about all these different edge cases and solve it fast, right? So, okay, back to a technical question. So for example, we ask a developer, create a function that does X, Y, and Z. Okay. Candidate solves it, let's say really quick, 1 minute. Another candidate solves it in 10 minutes. Okay, obviously this candidate is better, right? But we also got to look at those different edge cases. Did they solve it for all 3 edge cases? Okay, if they did, that's good. Okay, maybe they solved the first 2 edge cases really quickly, but the third one, that took a really long time and so forth. Okay, all right. But at a high level, what I'm trying to say is what is done when you ask an experienced interviewer to interview someone and tell you at the end of the interview how good that person is. You're basically just asking them, based on the distribution graph of people that performed in your past interview who were asked the questions that you asked, how well did this person do? Okay, so the way that I would put this graph, for example, is let's say there are different ways that you can look into the graph, but maybe the top 10%, let's say over here, solved it in less than a minute. And then, maybe 50%, solved it maybe from 1 minute to 5 minutes. And then maybe, most of the bottom, but usually more than 80% of them solved it within 10 minutes and so forth, right? What is usually done is when we ask these questions to different candidates, in our mind, we kind of build a distribution graph. And they intuitively, it's not really intuition, it's based on data, we can tell whether you're in the top 10 percentile, top 25%, whether you're average, below average, and so forth. When you do this with question 1, and then when you do it with question 2, and then question 3, and so forth, you basically build a combination of different distribution graph of how all the other people did on that question, on each of the questions that you asked. So here I'm having question 1, question 2, question 3, 4, 5, 6. And if that person consistently performed in the top 10 percentile here, now you know based on these 6 questions that most likely this person has high programming IQ and they're in the top 10%. You can draw that conclusion, right? On the other hand, if you ask these questions that had different distribution graph for each of the question, and maybe they were in the bottom 10 percentile for the first question, but then somehow things clicked and they now are starting to perform really well, you know that maybe that was an exception. Maybe they were just nervous and so forth. But by building and compiling these distribution graphs for different questions, you can, with data, confidently say whether they're in the high programming IQ, low, or average, or super high programming IQ, all based on data. So with programming IQ, what we do intuitively, and without even knowing that's what we're doing, is what we try to put into data compass programming IQ, so that every single question that's asked, we measure how fast did each candidate solve it, and how accurately were they able to solve it for all the different edge cases. We build a distribution graph for lots and lots of questions, and then we ask a series of questions to your candidate, and then we find out, based on our data that we compiled upon thousands and thousands of developers who were asked the exact same question that was asked for your candidate, this is how the distribution graph for the other candidates look like, and this is how your candidate did. Based on question 1, question 2, question 3, we will say with confidence that most likely your candidate has such and such programming IQ. Once you find that they have good programming IQ, then I would have more leniency. Even if they don't know a particular language or framework, then maybe you can give them some time to get familiar, and you focus on some high-level concept instead of a specific question related to that specific framework and that version, so that you don't miss candidates with high programming IQ who may just not have time to learn particular frameworks and tools that are being used in the company that you're working for. Okay?